Okay, so we're looking at zeros today. That's the name of the game. Why are we looking at zeros? I want you to think about it. Remember, we're working our way up to being able to look at the equation of any polynomial we see, rational or not, and graph it based on its major characteristics. Well, one of its major characteristics are where does it cross the x-axis, right? Because that's really, if you think about it, what are the zeros? They're where it crosses the x-axis. And what do we call points where it crosses the x-axis? X-intercepts, yes. So we know the x-intercepts, y'all should be fond of this, are also called zeros. And guys, not only are they zeros, they're also sometimes referred to as roots. Okay? The roots of a function. Those are going to be where this thing crosses the x-axis. So we need to be able to figure out, number one, how many do they have? And then where are they? Right? Well, we know how to find the x-intercepts of a function, don't we? So let's go through the basics of where do we find zeros. Polynomial function of degree n can have at most n real zeros. Think about it. If it's a cubic, the most it can cross the x-axis is 3 times. Think about what a cubic looks like. Cubic looks like this, doesn't it? Well, if we exaggerate that, it could look like this, couldn't it? Which means that at most it could cross, this leg could cross, the one in between could cross, and this leg could cross, couldn't it? That's it. So, if it's cubic, the most it can cross is 3 times. Does it have to cross 3 times? No, it could cross, but it has to at least cross how many times if it's cubic? At least once, doesn't it? Think about it, guys. If one end goes up and the other end goes down, it has to cross at least once, doesn't it? So odd functions are going to have to cross at least once, correct? Can it cross just 2 times? No, it can't, can it? Think about it. If it crosses once, if it's going to be enough to cross again, if it comes back up over the x-axis, it's going to have to go back down again, isn't it? So it can cross 1 time, or we can add +2 to it until we get to n. Does it make sense? So it can cross 1 time or 3 times. Now if it's even, if it looks like this, it could cross none. It could cross once, or it could cross twice. If it's a higher degree, why wouldn't it cross once? If the vertex is on, couldn't it? Okay. So we've got differences in them, doesn't it? Now, can it cross more than twice? Think about it. If it's to the 4th power, it could look like a W, couldn't it? So it could actually cross as many as 4 times. All right, so we have to be careful about that. So an even degree polynomial has an even, what? Has an even number of real zeros. Now, it doesn't say no real zeros, or no real zeros, right? Because it could have 0. Has an even. An odd degree polynomial has an odd number of real zeros. Now, the solutions, how do we find those linear factors? We're calling them linear factors. Why do we call them linear factors? How do we find the zeros of a function? We factor it, and we set the factors equal to what? 0. Each one of those factor groups is what we call a linear factor. Okay? That'd be your, in parentheses, your x minus 2 or your x plus 3 times something else equals 0, doesn't it? So we factor and set those factors equal to 0. So linear factors are those. So the solutions to the equation and we said we had to factor it and set it equal to 0 are the zeros of the function. They're also called roots. So we've got 4 names we can refer to them as. Zeros, solutions, roots. What else? X-intercepts, right? So there's 4 possible names they can be referred to as. If x equals c is a solution, then x minus c is got to be a factor, doesn't it? In other words, it is a linear factor. Now, why do we refer to it as linear? because we have to get it down to x plus or minus something, and an x to the first power plus or minus something is linear, isn't it? We're not referring to it as linear factor because we know it would graph like a line. We're saying it's to the first degree. Okay? Does everybody understand that? It can't be x squared plus something in parentheses. All right. Linear factors are found by factoring. So let's do this. So let's factor. So for example, we're given f of x equals x cubed plus 5x squared minus 24x. Now some of you struggled with factoring before now. Hopefully it's getting better and you feel a little stronger with it. So what's the first thing I can factor out of this thing? X, can't I? Sure enough, x. That leaves x squared plus 5x minus what? 24? What two factors of 24 add up to positive 5? 8 and negative 3, right? Okay, think about it. If you had negative 24 here and positive 5 here, that would be positive 8 and negative 3, wouldn't it? What? Oh, sorry. Let me get this to where it looks right. Negative 24 here. So positive 8, negative 3. So that means this is x. This is x plus 8, and this is what? X minus 3, right? Well, these are the linear factors. Throw an f of x in front of it, and each one of those is the linear factor. So now that we have the linear factors, what are the zeros? How do I find the zeros? Yeah, set each one equal to 0, wouldn't we? So, you know the one people forget the most? The x, the plain bare x. What is the 0 there? 0. Set each one equal to 0. We get x equals 0, don't we? And then we get what? X plus 8 equals 0, so x equals negative 8. And finally, x minus 3 equals 0, so x equals what? So the zeros, in other words, the x's are negative 8, 0, and 3. And that's how we would write the zeros of our answer. Yeah, when you put it in there, least to greatest would be this typical standardized format for it, yes. All right, so let's practice a couple more of these. Most of them are quadratics, but they're not all going to be quadratics. Some will be quadratic form. So let's look at number 1. What's the first one? What's the first thing we can pull out of this? X. So what's left? All right, so we're going to go over here and we're going to say negative 10, but adds up to 3. What two factors multiply to give me negative 10, but add up to positive 3? Positive 5 and negative 2. So that means this is x times what? Yeah, and x minus 2, correct? All right, so what do I need to do next? Okay, so x equals 0. X plus 5 equals 0, and x minus 2 equals 0. So this becomes x equals negative 5 and x equals positive 2. So if I want the zeros, my 3 zeros are going to be what? And 2. Yep. All right. So let's look at number 2. Why is number 2 a little bit different? It's not quite as easy, is it? There's a number in front, isn't there? Well, that just means we're going to have to factor by grouping. So it'll take just a little bit longer. So what's the first thing I can pull out of every term, though? X. Do you get the key to these is turning them into a quadratic so that you can factor them? So if we pull out an x, we have 2x squared minus 5x minus 3. Now here's the thing. When we go over here, remember this is first times last, isn't it? So we have negative 6 up here and negative 5 here. What two factors of -6 add up to give me -5? -6 and +1. Anybody thinking -3, -2? Don't do that. Because those would multiply to give me +6, wouldn't they? All right, so now we've got to do this by parts. So now we have 2x squared minus 6x plus x minus 3, don't we? Does everybody understand why I'm doing it this way? We factor by grouping when we have a number in front of the squared term, don't we? Now what? Separate them into two groups. Remember, we're going to go right down the middle, aren't we? So what can factor out of the first two? All right, so we have 2x, and this ends up as x minus 3, doesn't it? All right, so then what factors out of the second two terms? Yeah, 1. So now I can finish up. What is my first factor group that comes out of that? What do they both have in common? X minus 3, don't they? Don't both groups have x minus 3? Are you seeing it? Don't just write. We pulled out a 1 here because remember these have to match, don't they? And the only thing that comes out of both of these is +1. So now what do both groups have in common? That can be factored out, x minus 3, right? And then what's left in the other factor group? 2x plus 1. Okay, so now what? Set them each equal to 0. X equals 0, x equals 3, and x equals what? Come on, guys, do it in your head. Yeah, move the 1 over and divide, right? So -1/2. And then we rewrite it as an ordered set of solutions. So what are my solutions? 0 and 3. All right. Any questions so far? You good? All right. So now look at 3 and 4. 3 and 4 are a little bit different. Can I factor an x out? Can I factor an x squared out? No. It's not in the last term. If it doesn't come out of everything, it doesn't come out of anything, does it? But what form is this in? How do we know it's in quadratic form? What's the relationship between this and this? It's exactly half of whatever this is, isn't it? So if you've got whatever this term is half of whatever this term is, and then there's nothing here, it's quadratic form, isn't it? So if it's quadratic form, all we have to do is, and there's not a number in front, all we have to do is figure out, okay, how do I factor that? So if we do this, we've got 4 in the top and -5 in the bottom. So what two factors of 4 add up to -5? -4, -1, right? So this is equal to what? Yeah, x squared minus 4, and these are not linear factors. They need to be factored still further. So what does x squared minus 4 and x squared minus 1 have in common? They're what? They're difference of two squares, aren't they? Remember difference of two squares? How does the difference of two squares, and you're right, they are perfect squares, but how did difference of two squares factor? X plus and x minus, right? So this becomes what? Yep, x plus 2, x minus 2. And then the other one becomes what? X plus 1, x minus 1. All right, so there are all my linear factors, correct? So now what? X equals what? Let's just go straight down. -2. +2, right? This guy becomes that, This becomes what? And this becomes, now we'll write them in order. So what are my factors? One and two, right? All right. So now let's try number 4. Number 4 is going to be the same way, except we're going to have to factor by what? Grouping. How do I know I'm going to have to factor by grouping? Because there's this big fat 9 in front, right? So let's figure it out. 9 times 4. Thank you. And what goes in the bottom? Negative 37. So what two factors of positive 36 add up to negative 37? Negative 36 and negative 1. So now we rewrite this, don't we? 9x to the 4th minus 36 what? X squared minus 1x squared plus 4, correct? Now what? Yep, cut it down the middle, right? So what comes out of the first two terms? Yep, 9x squared comes out of the first two terms. You're correct. All right. So if you pull a 9x squared out of both of them, what are you left with? Minus 4, right? All right, now what can I pull out of the second two terms? Negative 1. Because we know that whatever comes out has to match what's in the first set, right? So what should be in that second set of parentheses? X squared minus 4. Remember, these have to match, don't they? All right. So what are my two terms? Yep, x squared minus 4 and what?
Not x squared minus 1.
All right. Can we factor these further? Yes. So what does x squared minus 4 factor into? Yep, difference of two squares. X plus 2, x minus 2. All right. 9x squared minus 1. Is it the difference of two squares? Yes, it is. 9x squared is a perfect square. 1's a perfect square. So what does it factor into? 3x plus 1, 3x minus 1. All right, so let's figure out what all our x's are. What are my x's going to be from the first guy right here? Negative 2. From this guy, it's going to be what? From this guy, what's it going to be? Negative 1/3. And from this guy, it's going to be, so we write our x's, and we get from least to greatest, negative 2, negative 1/3, positive 1/3, and 2. Any questions so far? Biggest part of this lesson is, can you factor? Honest to goodness. That's it. Can you factor? Let's keep going and look at what happens. Uh-oh. Now we got 4 terms. If we've got 4 terms and we've got x cubed, x squared, x, and then that, what does that automatically lead you to think about doing? Factoring by grouping. Why don't you try, I don't know, try the harder of the two, 6. See if you can do number 6. We've already got 4 terms, so let's see what you can do here. And then we'll talk about multiplicity. And what does multiplicity mean? And why do we care? Oh, I see who's dinging my phone to death. many solutions do you think you should have here? At most 3, right? So far we've had the right number. Now we're going to get into what happens if you don't have the same number as n. Oh, wait a minute. I don't want to do that. I already got this. And then check your answer when you're done. Did you get it? I cannot stress to you how much you've got to be able to factor for the rest of this unit and the next. You've got to be able to factor these, and you've got to know what to do. All right? All right, so any questions on this? So we've seen 3 different varieties, haven't we? We've seen it where it straight up factors out. We've seen it where we have to, it's in quadratic form and we have to factor and factor again. And now we've seen it in sort of a cubic form where we have factoring by grouping, correct? Now, multiplicity. Why does multiplicity even matter? Multiplicity is the degree of its corresponding linear factor. What does that mean? It means sometimes the factors, the zeros, are repeating. Now, what do I mean by that? Well, yeah, it means that, what it means is that one of them is a vertex touching the, in other words, one of the points, whether it's a maximum or a minimum, is touching the x-axis. I want you to think about what that would look like. For this guy, it would look like if we had this and it had a multiplicity, it might come up, come back down and touch, and then go back up again. That means we have how many roots here? 2. This guy, this second root right here, though, that touches and goes, there's a decreasing, it's still a turnaround point, isn't it? That guy has a multiplicity of 2. That means when we factor, that particular root will show up as the same thing twice. And so we would write it in parentheses as a linear factor raised to the second power. So anytime you have a factor that touches the turnaround point, a maximum or minimum, right? Relative max or relative min, absolute max or absolute min, that touches the x-axis, it gives you a multiplicity, okay? We could have a multiplicity of 4. If we looked at this guy, and I don't know what the multiplicity is, but if this guy, since it's negative in front, we'll say, let's say this guy was like, looked like this. How many roots are we supposed to have here? That means that potentially that could be the same root to the 4th power. Now we're going to find out it could also be to the 2nd power, and we could have 2 complex roots too, but that's a little further down the road. All right, but just to foreshadow kind of what's going on. So does everybody kind of understand what multiplicity means? It means one of the roots is a turnaround point and is on, and if it's a root, it means it's on the x-axis. So it's going up and coming back down again. All right, so let's figure out what there are, and how do we tell if we have one of those by factoring? So what can we pull out of all of these? X. As a matter of fact, why don't you just go ahead and do this? X squared plus 10x plus 25. Go ahead and factor it out and see what you get. What multiplies to give you 25 that adds up to 10? 5 and 5. So what are my 3 factor groups? X and what? X plus 5 is a linear factor and X plus 5. Here's the thing though. We don't want to write this as x plus 5 times x plus 5 because we're not going to solve it twice for the same number, are we? So we write it as x plus 5 raised to the what? That shows us that we understand that one of those roots has a multiplicity of 2. What does the x factor have a multiplicity of? 1. The x plus 5 linear factor has a multiplicity of 2. So that's what we mean when we said state their multiplicities. So what are my roots? What are my zeros? 0 and negative 5. I'm going to put them in the proper order here. Negative 5 and 0. 0 has a multiplicity of 1. And negative 5 has a multiplicity of 2. Okay? Does everybody understand that? I think on your homework it actually gives you a table. It says what's the multiplicity, la la la. What's the factor, what's the multiplicity, what's the effect? Okay? We've already talked about what the effect is, doesn't it? Haven't we? If the multiplicity is odd, or even if the multiplicity is 1, what does that mean? It intersects, doesn't it? Okay. If it's even, what does it mean? It means it bounces off, doesn't it? What about if it's to the third power? It's going to intersect. If it's to the fourth power, it's going to bounce off, isn't it? So if it's an odd power, odd multiplicity, it intersects. If it's an even multiplicity, it turns around, doesn't it? We call that being tangent to the x-axis, okay? It's either going to intersect the x-axis or it's going to be tangent to the x-axis. So let's look at this. So what do we have here? When we get to the factored form of this guy, let's figure out what the factored form of this guy is. We know f of x, we know we can pull an x out, can't we? If you pull an x out of x cubed plus 4x squared plus 4x, what do you got? Yeah. X squared plus 4x plus 4, which turns into what? X plus what? And x plus 2, right? So this is x plus 2 squared. Now, you know what that means? That means I can graph this guy pretty darn accurately, too. Not perfectly, but pretty darn accurately. Where are my roots going to be? Where are my zeros? I have a 0 at what? Negative 2 and a 0 at 0. So I know I have a 0 at negative 2 and a 0 at 0. All right. Which one of those has a multiplicity of higher than 1? The negative 2 does, doesn't it? Now, I want you to combine this with what you know about end behavior. This is a what type of function? It's a cubic, isn't it? Which means it does what? That. So the end behavior says, so the general graph should look like this, shouldn't it? Which means that if this has a multiplicity, it means at this point it should be going down, shouldn't it? Because that's the end behavior. Now, we know that that multiplicity is 2, which means it's even, which means it does what? It just bounces off, doesn't it? Which means it's got to turn back around again. But now look, we've got another 0 there at 0, which means it has to what? It's going to have to turn around again, won't it? So it's going to have a minimum somewhere, and it's going to turn back around again, and at this point it's going to have to go up. Do you see all of a sudden now we've got this great information about, more information about how this graph works without even having to put it on my graphing calculator. I've got a much more accurate sketch now, don't I? Now, the only thing I don't know absolutely is where this guy is. And we'll figure out how to learn where that guy is at some point, okay? So when the multiplicity is even, the graph is tangent. We call it tangent. You remember what tangent means in geometry? It means you could draw a line and it would touch at 90 degrees to whatever that point is, doesn't it? Think about it. I want you to think about why this would be considered tangent. If we took the x-axis, it is pretty much 90 degrees to that at that point, isn't it? Okay. So when the multiplicity is odd, however, the graph intersects the x-axis at that 0. So now we've got this great information here. So they've done us a solid on number 9. They've given us all of the linear factors, haven't they? So let's go straight across. For this first linear factor right here, what is the 0? You'd set it equal to 0, wouldn't you? So the 0 is 1. What's the multiplicity? 2. So what is the effect? So we call that what? It's tangent, isn't it? All right, so what's the next 0? Three over 2, right? Bring this over, divide by that. 3/2. What's its multiplicity? And so that means it's what? Tangent. What's the last 0? -4. What's its multiplicity? Power is 1, isn't it? So it does what? Intersects. So we could graph this if we wanted to, going from left to right. We know what it's doing. We also know what its lead factor is. I want you to think about this. Its lead factor, I can tell you right now, is x squared, right? Times 2x squared, so that would be 4x squared, right? So x squared times 4x squared times x. X squared, and x. Put them together, what do you get? X to the 5th, don't you? And are any of these negative? So this is a positive coefficient of x to the 5th. So what does the graph in general look like? Doesn't it? Do you see how we're going to be bringing all this together? Is anybody confused about how I came up with x to the 5th? I just took this to this power. X squared times 2x squared times x. So that's x squared, that's x to the 4th, x, that's x to the 5th, right? And then I looked and said they're all positive. So positive x to the 5th, something x to the 5th, right? If I know the lead term, I know the end behavior. So I know in general what it does. So if I know in general what it does, I know where my zeros are, I know what the multiplicity is, I could sketch this guy in general already. So let's look at another example, number 10. What's the first thing we need to pull out of this guy? X what? Cubed. It all has an x cubed in it, doesn't it? So if you pull this out and there's x cubed in the front, what do we get? All right. Now what? Yep, x plus 4. Sorry. And x plus 4, right? Which means we now have x cubed times x plus 4 to the 2nd power. So what are my zeros? 0 and -4 only, correct? What's the multiplicity on 0? Which means it does what? Intersects. What's the multiplicity on x plus 4 or -4? 2, which means it's what? So I know in general this guy is going to do this, don't I? Yes? So if I wanted to do a rough sketch of this guy right here, I know I have at -4, it is tangent, and I know it crosses again at 0, don't I? So if it's tangent here, I know its end behavior from my rough sketch, the fact that it's odd and positive, right? Tells me this, which means this guy is going to come up bounce off here, go down again, and come back up through this and go that way. That's a pretty accurate sketch. Boom. You see what we're building up to. The last piece of the puzzle that we're going to put together is how to find those things right there without your graphing calculator. Any questions so far on multiplicity, factoring, how we find zeros? Let me look. 10 more examples. Okay, that would be the end of that one. And I think we're jumping straight into the next set. We've already done dividing polynomials, right? Notice I didn't give you those pages. You have those already with synthetic and what? Long division, right? So now we got to put that together with, so let's move on. What we know about factoring with division. In other words, if this gives us this guy and tells us one of the factors, we should be able to find the rest of the factors, shouldn't we? I want you to think about that. I can't factor this using, well, I could maybe factor this using factoring by parts, but it wouldn't work, would it? By grouping. How do I know this would not be factorable by grouping? I want you to think about it. What's the only thing you can pull out of this first two terms? X squared. So if you tried to go that route, x squared, this would be x minus 5, wouldn't it? Is there anything you can pull out of those second two terms that's going to give you an x minus 5 in parentheses? No, there isn't, is there? So you cannot factor by grouping here. But they've given me a factor, which means I can use, and this is conveniently got a 1 in front, doesn't it? If it's got a 1 in front, what can I, and this has got a 1 in front, what can I use? Synthetic division, can't I? So synthetic division means we have to set this up. For synthetic division, this minus 4 comes out to the front as a what? Positive 4. And now we're going to take this, and this is factors, coefficients in front are 1, negative 5, 2, and 8, aren't they? Synthetic division coming back to everybody now. Remember, setting it up. We love synthetic division. If it's got a number in front of the factor, then we got to use long division, and that's crappy. Hopefully we won't have to do that, right? So now, what happens to the first term? First term always what? Comes down. And then we do what? Multiply. So 4 times 1 is what? So we put that there, and then what do? Straight down. We add, don't we? So negative 5 plus 4 is what? Negative 1. And then we do it all over again. 4 times negative 1? Negative 4. 2 plus negative 4 is what? Negative 2. 4 times negative 2? Negative 8. How do I know that this should zero out? If it doesn't zero out, is it a root? No, it is not a root if it doesn't zero out, does it? So if you come up with anything, if it tells you it's a factor and you come up with anything other than 0 as the remainder, you've done something wrong. This has to be 0. So please double check yourself. That's the way to tell yourself, because if you bring that down as a negative 4, if you do the wrong thing and bring it over as a negative 4, it's not going to work out to 0, is it? So then you know, oh, wait a minute, I forgot to change the sign as it comes out, right? Remember, you change the sign as it comes out. So now what is this right here? X squared minus 2, isn't it? Won't that factor? Can't we factor a quadratic? So right now what we have is this. X minus 4 times x squared minus x minus 2. Well, guys, x squared minus x minus 2 will factor. What two factors of negative 2 add up to negative 1? Negative 2 and positive 1. So that means this now becomes x minus 4 And this part of it becomes x minus 2 and x plus 1. Boom. Now, do we have all of the zeros? What are my zeros going to be? Those are all linear, aren't they? This is going to end up being 4. This is going to end up being, and this is going to end up being, so negative 1, positive 2, and positive 4. We have 3 roots here. What is the multiplicity on all of these? 1. Does that matter? Do you think we're going to end up combining with multiplicity at this point? Yeah, probably at some point. All right. Long division or synthetic division? I think we're going to stop here because we're fixing to go to lunch. When we get back from lunch, we'll work a couple more examples, all right? We're going to put all of this together. Next time, we will start adding in what happens if we get something we can't factor that's a quadratic. It means it must be a complex number. In other words, not real solutions. Up to this point, everything's been real. What happens when we add in not real solutions? And what happens if they don't give me one of the factors? How do I find what possible factors are? How do I narrow it down? I think actually we'll be looking at that first. And then we'll be looking at, that's P over Q's, what we call P over Q's, remainder theorem. And Descartes' rule of signs. And then we'll be bringing complex numbers in. And by the time we're done with that, we can factor anything down all the way to linear factors. Even if we have to use the quadratic formula to do it. Anything that's a quadratic can be factored, whether it's real or imaginary. Okay? So like all of our units, this one starts pretty easy. And it's gradually, at this point, it's gradually going to start getting what? Harder. It's nothing you can't handle, though. You know, the funny thing is I don't think we'd end up going, we had such a bad time last year with virtual. I don't think we'll end up going virtual unless we have so many teachers out that with COVID that we can't staff the classrooms. You might go. Huh? Are you doing your work that you're supposed to have done this weekend?
I just finished the notes, though.
Good. That's all you're supposed to have done. Did you get them? You're supposed to have homework 1 done, and from last time, right? And then
This one,
notes.
finish the energy one?
Yeah.
Yeah.
And then today we'll do the other
All right.
in class. We got some stuff doing in class, so I think y'all will like this. See, that didn't take that long, did it?
Not for real.
Less time than the homework takes typically.
Yeah. Are we still doing a lab?
Yeah, we're gonna have a quiz next time, and we're gonna start a lab.
All right.
So, 'cause, we're gonna watch the video 40 through 47. Actually, I think it'll be time after next. I think we'll end it with a lab this week. What's Monday? It's Monday, right? So Friday we'll have a lab.
All right.
It'll be fun. I like this lab.
on her desk?
You just put it right there and email her so she left it. Click on her keyboard.
This
And then
stats.
email her saying that you left it. Is that what you have?
This is stats.
That's
Wait.
easy. That's easy. I can do that.
I have that math.
That's easy. I love it. All you just plug it in and back it.
Smells like wet dog in here. Smells like wet dog in here.
Yeah.
It's that dog food she's had over there for the last.
Dog food? Oh.
It's been over there for like a month.
I don't even know what this is.
You were gonna do physics?
Me?
Oh, that's what you said.
Okay. Wish I could read this. What that is.
You wanted to take physics?
I didn't say that.
Why not? Oh.
Connor, you're the one who said you wanted to.
I'm already a master of quantum physics, you know? Dude, I read up on my free time.
I'm not stressed. Oh, that's so I'm like a year ago.
You go drink some window. Does the same thing, but that's not the same thing.
Cameron?
I got
Oh.
I got zero.
Oh,
It's one.
I know.
Oh.
Don't know that. Actually, helping you out.
Dude, this see, I got negative 30 seconds.
Take away the 1, 0. What's the no x squared?
I did negative 30. That's why I'm winning. It's in fact not 10, it's in fact 12.
They not controlled all the playoffs. You got the Steelers in the playoffs.
The Steelers are gonna win. Come back, come back, team.
That's funny.
And then, like,
Steelers are gonna win.
It's funny because they're playing the Chiefs. They lost.
If the Steelers beat the Chiefs, then they win the whole thing.
Yeah, but the Chiefs are kind
That's
of.
what it's
Have you seen this?
The Chiefs are terrible.
They're so bad.
The Buccaneers are winning.
The Patrick Mahomes is, he's alright.
The Ravens are winning. Yeah. I guarantee you they lose in the NFC.
Has he even won?
Who?
I'm just calling. Green Bay gets to the NFC Championship and loses.
All right.
It's Steelers to the end.
Let's finish up.
I just want one.
All right. So we need to finish up here. Oh, I forgot to pause it. Oops. This has been recording. Okay, so here we go. It says you try. Given the polynomial function and one of its factors, use long division or synthetic division to write polynomial in factored form. Then give the zeros of the function. Why don't you guys try number 18 and see where you get. Can we use synthetic division for this one?
Yes.
Okay. So set it up using synthetic division and finish it out. Anybody tell me a possible pitfall in number 18 you need to be careful about? Okay, so you go from x cubed to x, right? So we don't have an x squared term, so what do we need to make sure we do?
Add a 0.
Add a 0. Okay, good. And then check your work, please. Okay. So let's look at, I don't know, let's look at another one. Any questions on this one? We good? All right. So let's see. One more. Let's do one more. Let's do this guy down here, number 21. What's the difference with this one? Actually, let's do 20 and then 21. Oh, 20. What's wrong with 20? Long division. Yep. So we better just put 2x plus 5 right here and figure out 6x cubed plus x squared minus 27x plus 20. Let's remind ourselves how we do polynomial long division. First term, right? So 6x cubed divided by 2x is what? Yeah, 3x squared. That goes right here, doesn't it? Then we multiply out and we get 6x cubed plus 15x squared, and then we change and do opposite signs, don't we? That should go away. X squared minus 15x squared is negative 14x squared, and we bring down negative 27x. Start again. Negative 14x squared divided by 2x. What do we get? Negative 7x, right? So that goes here, minus 7x. Multiply it out, negative 7x times 2x is negative 14x squared. Negative 7x times 5 is negative 35x. Change your signs. This goes away. Negative 27 plus 35 is 8x. Bring down the plus 20. Should this work out perfectly with no remainder? Yeah, if it's a root, right? So now we just need to figure out what this goes into. So we have 8x over 2x, which is just, so this is plus 4. We know it's going to work out, don't we? So now what we know is this is 2x plus 5 times 3x squared minus 7x plus 4. Now what? Now we have to factor that second term, don't we? So let's factor it. Factor by grouping, right? 3 times 4 is 12. Adds up to negative 7. What factors of positive 12 add up to negative 7? Yep. Negative 3 and negative 4. So now we have 2x plus 5 times 3x squared minus 3x minus 4x plus 4. All right. This has got all the fun stuff in it. Divide it down the middle. What can we pull out of the first two terms? Three x, right? And we're left with what?
X plus 1.
What can we pull out of the second two terms? Negative 4. And we're left with x minus, remember we need those to match, right? All right. So my final factored form would be 2x plus 5, x minus 1, and 3x minus 4, leaving me with a 0 of negative 5 halves, 1, and positive 4/3, right? Anybody confused about where anything came from? Are we good? Are you sure? So we have 3 x's, 3 roots, negative 5 halves, 1 and 4/3. Let's do the last one. Do we have to use long division on this one? No, and we sing hallelujah, don't we? All right, so we can use synthetic division. 1 goes here. Setting this up, 4, 3, 2, 1, 0, so we don't have any skipped terms. 2, 1, negative 11, negative 4, and 12. 2 comes down. 1 times 2 is 2. 1 plus 2 is 3. 1 times 3 is 3. Negative 11 plus 3 is negative 8. 1 times negative 8, negative 8. Add them together, you get negative 12. We better get negative 12. Negative 12 here, and 0. Boom. Okay, so that leaves me with this. X minus 1, and since this was x to the 4th, this first term must be what? If this is x to the 4th, this first term must be what?
X cubed.
X cubed, right? So 2x cubed. So now we have 2x cubed plus 3x squared minus 8x minus 12. Now what? What's the only thing we have available to us at this point? By grouping. So we're going to split that down the middle. What can I pull out of both of the first two terms? X squared. Leaves me with 2x plus 3. What can I pull out of these second two terms, keeping in mind what needs to end up in my parentheses? Yeah, negative 4. 2x plus 3, right? So now this leaves me with x minus 1, 2x plus 3, and then what?
So x squared minus 4.
X squared minus 4. Are we done? Why are we not done? Because we still got a squared. It's not all linear factors, is it? This can x squared minus 4 be factored? Difference of two squares, right? So we're left with x minus 1, 2x plus 3, x minus 2, and x plus 2. This gives us 1. This gives us negative 3 halves. This gives us 2, and this gives me negative 2, doesn't it? So all of my factors from lowest to highest, negative 2, negative 3 halves, 1, and then 2. Take a second and think about it. Is there anything there that you saw that you don't understand? Either where it came from, why we did it, what's going on? Give me a thumbs up, thumbs sideways, thumbs down where you think you're at with this. Sort of, I got some sideways, I got some up and down. I'm hoping these turn to this once you do a few of them on your own, right? You've got a little bit of time left, go ahead. This is the end of the notes. You have 4 of these problems to do in homework 5, and then you've got all of homework 4 to do. Remember, you've already done most of homework 5, as it was.